Newton's first law is also known as the law of inertia. This basically says that matter prefers to maintain its velocity rather than changing it when not acted upon by any force. This means that if something is at rest, it will like to stay at rest, or if something is moving, it will like to stay moving unless acted upon by another force. For example, if I were to push a box in a vacuum with no friction or air resistance, then it would continue moving forever. If I were to push a box on Earth, it would stop because of all the friction and air resistance in the atmosphere. Keep in mind that Newton's first law is specific to only velocity. This is because, for example, in a car, if the car makes a turn and you want to continue going forward, that's not necessarily a change in speed but a change in direction, which is what velocity is used for. You can keep a constant speed but change direction, which is not an example of Newton's first law, as there's an unbalanced force changing your direction. Ultimately, the tendency to maintain your velocity is known as inertia. Newton's second law, in my opinion, is the most simple to understand, yet the most useful in understanding physics equations and rearranging. It states that the force is proportional to the mass multiplied by the acceleration. Most will say F equals ma, but what does that mean? I could say F is the number of bananas, and A is the temperature of the surface of the sun, multiplied by N, the rating from 1 to 10 that little Timmy in the school nurse's office rates his pain when he ran into the classroom window. But all jokes aside, yes, that was a joke. I expect laughing now. All jokes aside, the F is equal to the force, measured in newtons, which is a vector quantity, so it has to have a direction, which is equal to m, which is known as the mass in kilograms of the thing that is being acted upon, multiplied by its acceleration, measured in meters per second squared. Newton's third law is one of the most misunderstood scientific concepts that have ever existed. The idea of throwing an apple up and it coming back down is definitely not an example of Newton's third law. I like to word it like this. Every action force on any matter results in an equal and opposite reaction force from said matter. This means that for any force that is enacted, there is an equal and opposite resistance force acted back upon the original source of the first force. See, if I were to push a wall, it would look like nothing happened. This is because when I'm exerting a force on the wall is providing an equal and opposite resistance force back onto me. And since I'm not rigidly connected to the earth, unlike the wall, I would push myself backwards. But it's not me pushing myself backwards, it's actually the wall pushing me as a result of me pushing the wall. Another reason why Newton's third law is so difficult to understand is that individuals think that if every action has an equal and opposite reaction, then nothing would move because everything would cancel out. This, however, is not true. Think about it in frictionless space. If I were to push something, then we would end up both travelling in opposite directions for an unlimited period of time. If I enact a force on another object, I don't necessarily need to maintain my position. I'm allowed to use the reaction force to propel me backwards.